Hi y'all, today I'm going to be showing you and teaching you about physical and chemical changes. So physical and chemical changes are part of the observing change and the particle theory. So what is a physical change? Well, a physical change is when no new substance is formed, there's just a change of state. It's called a physical change. Well, there's no change of particles, just their range and their energy. And a chemical change would be a new substance is formed, and chemicals are usually very difficult to reverse. I'm going to be explaining this in further detail in today's video, and I'm going to be explaining it simply. That was just a little bit of, a little tiny bit of a crash course, an intense period of learning, but I'm going to be making it very, very simple for y'all. Okay. Alright, so say we have chocolate. Okay, I'm just going to kind of draw that. So say we have about a bar of chocolate. Okay. Alright, so we have a bar of chocolate. Now we're going to talk about this bar of chocolate if it were to be a physical change. So if this bar of chocolate were to be a physical change, we're going to discuss what would happen. Sorry, that's not very neat, but... Right, so... keep in mind that physical change is if there's just a change of state. So it is still chocolate, but it's just a change. Well, okay, so keep in mind, when we're talking about physical change, we aren't saying that a new substance is going to be formed. So we're not saying that something new is going to come. It's just going to be the same thing, just a change of state. And remember that the states are solid, liquids, and gases. So for example, it could be a liquid or it could be a gas. There's just a change of state. It's not going to be a new thing. It's just going to be chocolate in a different state of matter. So I'm just going to explain this theory very, very simply to y'all today, just to make sure that you understand fully. So basically, we're going to be talking about chocolate's just an example, obviously. It could be almost anything when we're talking about physical changes. So we're going to be talking about chemical changes later on, but we're going to be mainly focusing on physical for now. Okay, so how could we just change the state? Sorry, that's not very neat, but how can we just change the state in the physical change with the chocolate? So how could we keep it chocolate, but just change its state? How is that possible? Well, let's take a look at our 3 states of matter, which we actually did in one of our videos, so you might want to go check that out. But anyways, back to the video. So our 3 states of matter, as we know, are solids, liquids, and gases. So our bar of chocolate is already a solid. A liquid or gas would be something different. But it's not like we're going to condense the chocolate as a solid. Oh, no. So we can't just put the bar of chocolate and boil it. No. That's not going to be possible just yet. We're not going to turn the chocolate into gas, because there's something else that we need to do before we do that. We need to turn the chocolate into a liquid, aka melt the chocolate. No room for the E, sorry. So we just need to melt the chocolates. Basically, it's turning into its liquid. state. So the chocolate, if we melt it, it's going to be turning into a liquid state. And if we melt it and our chocolate is now melted and it's in its liquid state, then we can boil it and turn it into gas, which could be a steam, which is basically called condensing the liquid. So that is how we can transform it into a liquid and a gas by just making it into a liquid. So you're obviously going to need to melt the chocolate. But if we melt the chocolate, do you think that it's a physical or chemical change? Well, it's obviously physical because it's still chocolate. We're just changing the state of matter. For example, before it was a solid, as it was just a solid bar of chocolate. Then we melted it and it became a liquid because, well, not obviously water, liquid or anything, but it became a liquid because it was melted. Now let's talk about a chemical change. If we were to have a chemical change, then a new substance is formed. So a new substance would obviously have to be formed. And they're very difficult to reverse. So we have to make, basically, in the simplest terms I could possibly think of. Oh, this whiteboard is not big enough. But we basically just have to make something new. And in chemical changes, they're basically going to be very difficult to reverse because you're not making them just into a new state of matter. You're making them into a totally new thing. So how can we do this with our chocolate? Well, what if we put the chocolate into something new? What if we put the chocolate... Oh, sorry, this is a very bad cake. But what if we put the chocolate into a cake? It would be very hard to reverse, wouldn't it? And it's something totally new now. It's a cake, a chocolate cake. So you see, the main point of this here is that I wanted to show you that physical and chemical changes are very, very simple to learn. For example, in a chemical change, you're just going to have something new. And I'm not sure if I'll have room here, but in a physical change, there's only going to be a change of state. So you could say it's something totally new, but really it's the same thing. It's still chocolate, but it's just a change of state. No, very sorry, this isn't neat, but I'll probably have something typed out because my handwriting on whiteboards aren't very neat. But I hope you get the basic idea. So physical changes are basically when there's no change in particles, just arrangement and their energy. Basically no new substance is formed, it's just a change of state. And the chemical change is usually very difficult to reverse because something new is formed. A new substance is formed. With a chemical change, something new is going to be made, and it's very hard to get. And if you want to know if a chemical reaction is taking place, here are some signs that indicate that this has occurred. Color change, a change in temperature. Light is emitted, bubbles of gas are produced.